And welcome to this new lesson in which we are going to start with our first example. It will be a basic example in which we are going to create a web server using our board, the ESP32, and we will use the IP address to access our ESP32. Then we will see how we can add the OTA to our code so that we can easily update the software on the go without connecting wires wirelessly or over the air. Now, the first thing is including the libraries. So let's include our first and most important library, which is the async elegant OTA library. Now the second library will be the async TCP, the one that we installed manually. So write async tcp.h. Now the async TCP is the library that we installed manually, and as you can see it is here. So if you clicked here it will be added, but we just wrote it, so we'll delete this. I'm just showing you that it is installed. Now we also need to include the ESP async web server library, which is the third library that we manually installed, and you can also see it here. If you went down, ESP async web server library, and you can also click here, it will add all of these, but we don't need all of them. We just need the ESP async web server, which is this one. Now once you are done, you will also need the Wi-Fi library because we need to enable Wi-Fi on our ESP board. So simply write Wi-Fi.h. This is the header file of the library. Now these are the 4 libraries that we will need. Let's also create the 2 main variables for our Wi-Fi connection. Constant character. So we'll create a pointer, call it SSID. And in here, you need to add your Wi-Fi network SSID. And we also need to create another pointer for the password. And when I say pointer, this asterisk sign means that here we are defining a pointer. The type of this pointer is character, and the name is SSID. Now, pointers is explained in our C programming course. Now, after doing this, we need to start the web server. So we'll create an async web server object on a specific port, and for this example we will use port 80, which is the default port. So async server, and here you need to add 80. Now I usually like to verify my code before moving forward and save it so that your work won't be lost. So let's create a new folder, call it codes, and let's call it simple code ESP32. Now verifying the code will help you know the errors as they happen. Now we have few lines of code, and if we have an error we can easily fix it. Now go to the tools. Here we have an error because we have the wrong board selected, Arduino Mega. So we need to go back, change the board to ESP32, and the one that we will use is DoIt ESP32 dev kit version. So again, verify. Okay, now done compiling without any errors. Let's initialize the serial monitor. So write serial begin and 115,200, which is the baud rate for this serial. After that, we need to initialize the Wi-Fi, and the Wi-Fi code is pretty straightforward. we usually write it or copy it from anywhere. We will start by enabling the Wi-Fi mode, and we will use Wi-Fi STA. After that, we will begin the Wi-Fi connection with the given SSID and password. So SSID, password. Then we will start the serial monitor by printing an empty string. Or you can say Wi-Fi connection attempt. Then we will write the famous while loop that will keep printing dots if you are not connecting to the Wi-Fi network. So here we have our while loop. So if not connected, we need to wait for like 400 milliseconds, and then we will print serial.print, and in here we need to write a dot inside the while loop that will make sure if Wi-Fi is connected. If Wi-Fi is not connected, it will keep printing dots and trying to connect. Now write Wi-Fi status, which is a function that will return the status of our Wi-Fi network, and write connected. And by the way, this is called a C macro. So this is usually a number written in the Wi-Fi library. So CONNECTED. So if not connected, keep printing dots. Wait, keep printing dots, and so on. Now, if it is connected, we need to print few lines. So serial.print ln. We will start with an empty line, and I will print few things. Connected to Wi-Fi network with name, and then we will print the SSID because it has the Wi-Fi network name using the print without printing a new line because we need it to be printed on the same line. Now you can even get the IP address, which is something we want because this IP address will be used to access our ESP board. So we will write print IP address for Wi-Fi, for ESP, sorry, 32. Then we will use the local IP function, print new line, Wi-Fi.local IP. This function will return the local IP for our ESP board. Now, after doing all of this, we are connected to the internet, which is the first step in our program. The step after this is to handle the client requests. So we are going to write 2 or 3 lines of codes to send any text like, hi, hello, this is Ashraf, or this is education engineering team, and your ESP32 board is online. Now, this text will be printed whenever you access the root IP address. And to do this, we can simply send this line of code. Write server. And when we say server, we mean the server that we initiated here. So here we are calling the object, which is server.on. Then you need to add 2 parentheses and a semicolon. Now between the 2 parentheses, you have to add 2 double quotation or double quotes, then add a semicolon. Now we added backslash. After the semicolon, we need to send the request, which is HTTP GET. Then add another semicolon, add 2 brackets, and add 2 parentheses. Now between the 2 parentheses, we need to write async async web server request asterisk request. So this is basically a pointer. Now after that, we need to send the request itself between two curly braces. So write request, then write send. After that, you need to add two parentheses and add a number, then the type of thing you want to display. It will be text plain, and we need to add another semicolon, then add the text that you want it to display. Let's say hello, this is Ashraf, educational engineering. That's it. Now let's do this on 2 lines of code. Now we have, okay, we can split it here. That's it. This will be our code. Now this is the server.on. After that, we added 2 quotations and a backslash, semicolon, the request type HTTP GET, another semicolon, 2 brackets, and 2 parentheses. Between them, we created a pointer called it request from the async web server request type, which is a type from our library. Then we added 2 curly braces. We sent the request, and the type of data that will be displayed is text. And this is the text that we will display on our web page. Now, once done, we have the request ready. The last step inside the setup is starting the elegant OTA server. So make sure you are here, write async elegant OTA dot begin, and we'll pass the server address. So add and server. This will pass the address of our server memory to the begin function of the async elegant OTA, which is the over the air update library. Then we will start the server itself, write server begin, and we will print on the serial monitor anything to indicate that the server started. Elegant OTA initiated, and we need another line. Here we need to write HTTP server has started successfully. Now, once you are done, this is the end of our code. As you can see, we have our elegant server started, we have our web server started, and we have the text to be displayed on the root IP address. And this code is ready to be shipped to our board or ESP32 board. Now, let's verify the code again to see if we have any errors to fix them before uploading the code. Now, in the next lesson, we will upload the code and we will test this practically and see how we can send our bin file. Now, as you can see, we have an error here. It's saying that it expected us to write a semicolon before the curly brace here. So let's see. Okay, here, that's right. Here we have missed a semicolon at the end of this request. So make sure that you have the closing parentheses, semicolon, curly brace, closing parentheses, and another semicolon. Click verify again. This structure is something you can copy, you don't have to memorize. And we will provide the code for you to check out. But we usually like our students to write their own codes so that they will learn along the way. As you can see, done compiling. Now what is left is uploading the code to our ESP32 board. This will be done on the next lesson. So now let's do a quick overview of this code. First, we imported the async TCP, the web server library, and the elegant OTA library, which is the main library for our course. We also imported the Wi-Fi library because we need to enable Wi-Fi connection. We created 2 pointers, SSID and password, for our Wi-Fi network name and password. We created an object from the async web server, called it server, and the port will be 80. Inside the voice setup, we started the serial communication. We choose the Wi-Fi mode to be Wi-Fi STA. We began the Wi-Fi connection with the Wi-Fi network name and password. Then we printed Wi-Fi connection attempt. We use the while loop to check if Wi-Fi is connected using the Wi-Fi status function, and if it is not connected, it will keep printing dots and waiting for 400 milliseconds. Then, once connected, it will print connected to Wi-Fi network with the name printed of our Wi-Fi network. Then it will print the IP address for our ESP32 board. After that, we sent a GET request to our web server to display this text on the root web page. Then we started the OTA with this server address, and we started the server itself. Then we printed these 2 lines: elegant OTA initialized, HTTP server has started successfully. Now we can also print another line to access OTA update. Type, and after that we will use the local IP address in here, and we will print this sign with the backslash sign, and the last step will be printing the word update. So this will show the user what he needs to enter to access the OTA update page. Once done, simply click verify again. And again, in the next lesson, I'll show you how to upload this code to your ESP board and how you can easily update the code using OTA feature without any cables. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team.